Good evening. Today we are going to solve the problem which were given on Saturday. Now question we have, find the ultimate moment of resistance of a L beam for the following data. Width of flange 1200 mm, depth of slab 110 mm, effective depth 600 mm, width of web 300 mm, tension reinforcement 7 of 25 mm diameter, use M20 and Fe415. So this problem that is of T and L, so we have to keep in mind it may be T or L. So if we have L, then we have in this fashion, we have to write down the data of this. So we will write one by one all values in this diagram. So we have given width of flange 1200 millimeters. So we will show width of flange 1200 millimeters. L, so we have slab only on one side. So these are generally corner beams or along the periphery of the structure. Then we have given effective depth 600, depth of slab 110. So we have this is depth of slab. Then width of web 300 mm. So we have width of web 300 mm. Then tension reinforcement, we have 7 bars, 25 mm diameter. So we have these bars as 7 bars of 25 torr because it is given Fe 500. So if you will calculate this area, then we have this area that is 3436. So I will write AST equal to, so we can find 7 into pi by 4 into 25 square. And then we have this value 3436.12 millimeter square. So we have to now solve this problem. So what is given? So we have given M20. So given data you can write. So we have given M20. Then we have given Fe 500. So we have first assumption. Assumption. So we have neutral axis lies in flange. Neutral axis lies in flange. And when neutral axis lies in flange, so we have 0.36 FCKXU into BF. This is most important, equal to 0.87 FYAST. Now put the value, we have 0.36 FCK20 into XU, BF we have 1200 equal to 0.87 FY we have 500 and AST we have 3436.12. Now if we will solve this, we will get value of XU that is equal to 173 millimeters. So we have this value that is 173 millimeters. So just I will rub this. So we have 173 millimeters. Now this value is greater than 110 millimeters, which is depth of slab, and therefore assumption is wrong. Therefore, assumption is wrong. That is, neutral axis lies in web. Neutral axis lies in web. Now in this again we will go assumption. DF less than 3/7 of XU. What does it mean? So we have uniform stress in flange. Uniform stress in flange, which is 0.45 FCK. And then we can have equation 0.36 FCK XU. Now keep in mind this is BW. So now we are making it into two parts. One part we are going to say as a rectangle. This one. And therefore 0.36 FCK XU BW plus remaining part we have 0.45 FCK. This will be uniform stress into BF minus BW. BF minus BW into we have that is depth of flange DF and which is equal to 0.87 FYAST. Now put it, so I have calculated this value actually over here. So we have this will be 0.36 FCK is 20. XU we have to find out and BW is 300. Plus 0.45 FCK is 20, BF is 1200, minus BW is 300, and DF is 110, and which is equal to, now I have calculated this value here only. And we have this value 1494. So we have, you can check it 1494. 712.2. 712.2. So I will directly write this value over here 1494712.2. And then we will find value of XU from this. So we will get this equation XU equal to 1494712.2 minus 891,000 upon 2160. Yes, upon 2160. Now this 891,000, we have value of this portion. This is 891,000 and 0.36 20 into 300, we have 2160. And from this we will get value of XU that is equal to 279.50. Now we have to check this value with XU max. Now we have this as 500. So we have XU max that is equal to, for 500 we have this value 0.46 and we have depth that is equal to 600 and this value comes 276 millimeter. So this is greater than 276 millimeters. So we have over reinforced section. Therefore section is over reinforced. And this is not allowed. And therefore we have to take XU equal to 276 millimeters. Now we have to find 3/7 of XU. And then we have 3/7 of 276. So we have 3/7 of 276. And we have this value which is greater than 110 millimeters. So we can have this value to 110 millimeters. Now you can calculate this. Just I will calculate 3/7 of 276. So we have this value 118.29. So we have 118.29 and greater than 110, and therefore our assumption is correct. Therefore assumption is correct. And now, as assumption is correct, so we have to go for bending moment. So assumption is correct. And now we will write equation for bending moment. And we have this equation, MR, not bending moment, MR. So we have 0.36 FCKXU into BW. This is a rectangle with BW width in bracket D minus 0.42 XU plus 0.45 FCK in bracket BF minus BW into DF in bracket D minus DF by 2. And then we will substitute value 0.36 into 20 into now 276. Keep in mind into 300 into D is 600 minus 0.42 into 600 plus 0.45 FCK 20 BF we have 1200 BW we have 300 DF we have 110 D we have 600 minus 110 by 2. And now you calculate this value. So I have two values. One value we got first 288.59 into 10 raised to 6. 288.59 into 10 raised to 6 plus 485.6 into 10 raised to 6. And from this we will get value equal to 774.19 into 10 raised to 6 Newton millimeter. And we have MR equal to 774.19 kilonewton meter. So we have, this is moment of resistance of L beam. So now we will stop here only. Remaining part we will see in the next lecture. Thank you.